to continue with section 11.1 today. And in all reality, we could have put all of 11.1 together. It's just that like that whole introduction to the 3D system, the octants, the graphing of the points, the new dimension, for some of us that can like throw us off just a little bit. So we wanted to give you time to get comfortable with how the 3D system works. So we split that up. The next two sections that we do, 11.2 and 11.3, we'll just do in one day. Tuesday and Wednesday, we'll review on Thursday, and you guys will be testing on your finals day. So this is Notes 11.1b. We're basically going to talk about midpoints and sphere equations. So first we're going to start with the midpoint. You did distance and midpoint probably even before geometry. But does anybody remember how you calculated midpoints in geometry, algebra? I think you're thinking of distance, which we did on Friday. Liam?
Is it x1 plus x2 over 2?
Add up the two x coordinates and divide by 2. Add up the two y coordinates and divide by 2. What are we going to do in 3D? Add up the z coordinates and divide by 2. Like, we'll do all three of them. So what you're doing there when you're adding up the x's, x sub 1 plus x sub 2 divided by 2, you're basically calculating the average of the x's, which makes sense because the midpoint should be in the middle. To find the middle of something of two terms, we would just find the average of those two terms. So x sub 1 plus x sub 2 divided by 2, and then you'll have a separate y sub 1 plus y sub 2 divided by 2, and then a z sub 1 plus z sub 2 divided by 2. Now, if you look back to the distance formula on Friday, when you take your two coordinates, you find the difference. So you're like subtracting the x's, subtracting the y's, subtracting the z's, squaring them, and adding their squares together. So you kind of have to make sure that you're familiar with those formulas. I'm also going to put a note right here that says my answer should be an ordered triple. Every now and then I get people who maybe just like aren't really thinking about what a midpoint represents. A midpoint represents a point in the middle of two other points. So all three of those things should be listed as points, x, comma, y, comma, z in 3 dimensions. You don't want to like add those things up or get like one single number answer like we do for distance. Distance comes out to be one single numerical value because we're just finding the length between 2 points, and length is a number. Here we're finding a point, so we should have each coordinate. If you haven't already, will you go ahead and find the midpoint for these 2 points? 2, negative 2, 4, and 1, 3, 6. And I'll put my answer up here in just a moment. For the sake of my notes, I'm going to show my work. I would also recommend you show your work on your test just so I know where your numbers came from. And then simplify. I should get 3 halves, 1 half, and 5. If you wrote 1.5, 0.55, that's the same thing. Okay. Any questions, concerns about finding midpoints? Okay, so make sure in preparation for your final exam, you guys are taking your final exam 4th hour on Wednesday of next week. Make sure that you review those formulas before you come in and you know what to do and you know what your answer will look like. All right, next up we're going to talk about the equation of a sphere. Okay, a sphere is most closely related to which two-dimensional shape? The circle. So over on the sideboard, I'm going to write out my equation of a circle. which you know from geometry. Also, we saw it pop up in our conic sections unit. The equation of a circle looks like the quantity x minus h squared plus the quantity y minus k squared equals r squared, where h and k represented what? The center point, okay? And just r was our radius. So if you have the circle equation equal to 4, remember 4 isn't your radius, r squared is equal to 4, therefore r is 2. So you always have to square root that number on the outside. Well, that's just in 2 dimensions. In 3 dimensions, we're just going to be adding a z part, right? So in the sphere in 3 dimensions, we call the center point h, k, and j. So then we want to add a z minus j quantity squared. So here's our equation for the sphere. X minus h quantity squared plus y minus k quantity squared plus z minus j quantity squared equals r squared. So essentially it's really the same formula, we're just adding that 3rd dimension, just like we did for midpoint and for distance. And I have just down here at the bottom, the center, of course, if you haven't labeled, the center is HKJ. This will work just like it did in our conic sections unit because the formula has them x minus h, x or y minus k, z minus j. When you take out h, k, and j, they look like the opposites of what they are. And then the radius is equal to r. So remember, this number that you see equal is not the radius, it's the radius squared. So you still have to square root that value out on the other side. Now, the last thing I have on this slide is just really like what I would call the definition of a sphere. And I just wanted to point out that the definition of the sphere is basically the same definition of a circle, but with now 3 dimensions. So a circle, we would say, what's special about a circle? All the points on the circle are equidistant from the center. So what's special about a sphere? All the points on the sphere are equidistant from the center, but they go now in 3 directions. So every x, y, z point on a sphere will have the same distance to h, j, k, which really represents its r, or its radius. Okay, so if you were thinking about building a sphere in 3D, like with your 3-dimensional systems, get my floor, got my x-axis coming at me, I would plot my center point, and then for whatever my radius is, I would count up and down, left and right, forward, back, and then imagine the round shape that would be all around that. Okay, so we got 2 examples to work on with spheres. Here's my first one. We're going to find the center and the radius for this sphere. When you see this, what immediately comes to mind? Tyler says, completing the square. So it doesn't look like the formula I just gave you, right? X minus h quantity squared, y minus k quantity squared, z minus h, or z minus j quantity squared. So we're going to have to make it look like that equation so we can identify our h, or our hkj. Got too many letters going around in my head right now. Okay, so what are some of our steps at the beginning if we want to rewrite something by completing the square? What kinds of things are we going to do to get going? Subtract 10, move that one to the other side, and then I think, Campbell, what did you say? Rearrange so that like variables are with their partners, right? So like x squared and x are together, y squared and y are together. Okay, so let's take care of that. I'm going to subtract 10. And then I'm going to rewrite so that my x's are together, x squared plus 4x. I'm going to leave some space. Plus y squared minus 2y, leave some space. Plus z squared plus 8z, leave a little space. And then that equals negative 10. Negative 10 doesn't have an x, y, or z, so it's not going to be a factor in any of our complete the squares. Remember, before you complete the square, you should always verify that your leading coefficient to your square term is a 1. Well, that works out pretty nicely for us in this example. We have 1x squared, 1y squared, and 1z squared, so we don't have to do any factoring out. Note that in order for this to be a sphere, the x squared, y squared, and z squared always have to have the same coefficient. I'll say like the majority of the time it's always going to be 1, but they could be like 2x squared, 2y squared, and 2z squared. So at the end you would divide by 2. Okay, now we're ready to complete the square. What number completes the square for the x's? 4. How'd you get that? 4 divided by 2, the middle term, 4x, divide its coefficient by 2, that's 2, and then square it, so 4. If I put a plus 4 over here, got to put a plus 4 on the other side. What number completes the square for y squared minus 2y? 1. This one can be really tricky on quizzes and tests. It got a few people on their final, and it got a few people on the Chapter 10A test numerous times. For some reason, when we're testing, negative 2 divided by 2 is negative 1, and then negative 1 squared is 2. But you got to remember, negative 1 times negative 1 would just be positive 1. So that's a plus 1. Put a plus 1 over here. And then what completes the square for the z's? 16. Half of 8 is 4, squared is 16. Add that to the other side. Okay, so now we're just kind of in the cleanup stages. Why did we do what we did? So we could write them as x minus h, y minus k, z minus j. So this trinomial, x squared plus 4x plus 4, will factor to be x plus 2 times x plus 2, which we could write as x plus 2 quantity squared. Plus y, watch your sign here, since it's minus 2y, it's going to be a minus 1 squared plus z plus 4 squared, and then add up all these things, it should equal 11. Good way for you to kind of check things. Never should your sphere or circle equation ever equal a negative number at the end. The r squared should always be positive. So if you do have it equal to a negative, I would guess you probably didn't add to both sides. So that's like a good, like, oh no, it equals a negative. Did I add to both sides? And personal check for you. Okay, what is your center point? Negative 2, 1, and negative 4. Excellent. What is your radius? Square root of 11. So r squared is equal to 11, therefore r must be the square root of 11, which is like probably like 3.2, 3.3, something like that. Now, take a quick minute to imagine this on your three-dimensional coordinate system. If you want to use the ones that are in front of you, if you like to see that, you can. I'm going to orient it so my x-axis is coming forwards and backwards. That's the intersection of the xy and the xz plane. And then my y-axis is going left and right, and my z-axis is going up and down. Okay. If I were to start plotting this sphere, I would plot my center point. I start by going negative 2, so from my origin, I'm going to go 2 back. Then I've got a positive 1, so I'm going 1 to the right. And then I have a negative 4 for z, so I'm going 4 down. In which octant is my center point located? That's octant 6. 5 is in front under 1, 6 goes in the back. Okay, so I'm in octant 6. And then to build my sphere, I would count out from that point the square root of 11. So I could count up square root of 11, down, left, right, forward, backward, and I would have a little sphere living right down there. Okay. Last one I'm going to give you, and you're going to work it out with your pods, and we'll kind of talk about it together. We're going to find the standard form equation for the sphere with this information, and then I'm interested in knowing, does this sphere intersect the xy plane, and most importantly, what is your reasoning? So that's something I want to talk about with your pod mates. Nice. Okay, check the board. Our equation of a sphere should all be the same. You could write equal to 4 squared, but I would kind of get in the habit of like actually squaring that number and saying that that's equal to 16. Because that maybe will just help you if I give you this equation and ask you what the radius is, so you remember to take the square root of 16. So I think sometimes when people don't see the square, then they just write the number down. Okay, so be careful with that. Okay, does the sphere intersect the xy plane? I'm seeing a lot of yeses. Can someone raise their hand and tell us their reasoning? Why does the sphere intersect the xy plane? Jayla.
So you go down 2, and so your radius is 4, so you'll have to pass the xy.
Excellent. Okay, the xy plane is the floor of our diagram, right? The yellow. And just like Jayla said, you go down 2. It wouldn't really matter which octant you're in the basement. Which one are you in?
5.
You're in octant 5, the front one. So you're going down 2. And then if you build your sphere with your radius 4, well, obviously you're going to cross that floor, and your top point is going to be somewhere in octant 1. So yeah, you're going to cross the xy plane. What shape will you form at the intersection of the xy plane? It'll look like a circle. So that's like our cross section. Okay, kind of like the conic section of the cone. Okay, but that's just a cross section because it's not a cone. So the cross section of that plane would be a circle. You can also, just note, have some spheres that would intersect the plane and they be tangent to the plane. What do I mean when I say the sphere would be tangent to the plane? It would intersect at a single point instead of forming like some cross section that looks like a full circle. So imagine in this example, if we moved the center point down 4 and had a radius of 4, would we intersect the xy plane? Yes, at the single point that's on the plane. Okay, so you can also have tangents to planes. Excellent. Nice job. Thank you, Jayla. Here's your assignment. You can get started, and you should get finished.